Let us start with our second part of the lesson, in which you will be introduced on testing the goodness of fit for the probability distributions through numerical illustrations. So, as earlier mentioned, you went with the theory. Now we are going for a numerical illustration using a probability distribution. Now here you are going with a problem on a pair of dice are thrown 360 times and frequency of each sum is indicated below. As you know that when you are having a single die, you will be having 6 faces, that is 1, 2, 3, 4, 5 and 6. Here you are going with pair of dice. It means that you are rolling 2 dice. So then you are taking the sum on each face. So let us, you can see that the minimum sum will be 2, because in a first die you may get 1, in a second die you may get 1, then the sum will be 2. Likewise, you have been gone with the minimum sum and the maximum sum. Let us, you can see that in a first die if I got a number as 5, in a second die let us if I got a number as 6, 5 and 6, it means that 5 plus 6 will be 11. So you can see all the combinations has been presented over here. That is, the minimum sum will be 2, that is, if your 2 dice has got with the number 1, 1 plus 1 will be 2. If your dice has been gone with 2 6s, then the total sum will be 12, that is the maximum. Now here the frequency represents that here you have been pair of dice has been thrown for 360 number of times, among them 8 number of times you got 1 on 2 dice. Then similarly 24 number of times you got the sum as 3. It means that one die got number 1, the other die got the number 2. It may be vice versa also. In the similar fashion you have been went with all the numbers here. At the end 14 number of times you got the 2 dice as number 6, that is 6 plus 6 12. So this is the frequency they have been given. So here you have to identify whether the dice are fair or not. That is what you have been asking here. Would you say that the dice are fair on the basis of chi-square test at 0.05 level of significance, that is 5% level of significance. I can assure you one more thing, do not think about that every time I have to go for the 5% or every time I have to go for the 1%. Now you have been calculating everything in a software base, you can go with any number of percentages. It may be 10, it may be 11, it may be 12 or 12.5, whatever the percentage you can choose, you can move on. Earlier you have been went with only on the chi-square table based, then you have to restrict our values with our 5, 10 and 1. But whereas now in a software based techniques you can move on with any numbers. Now coming to this solution here, how you have been working. So what is the study first of all? To study if the dice are fair. First we have to compute the probabilities, then with this the expected frequency will be computed. As I mentioned in earlier sessions, when you are working for an expected frequency, you have to calculate your probability first. But whereas in your previous part you went with the regression model, so you obtained your expected frequency through fitting of regression model. Whereas now here you are moving towards your probability distribution, hence you have to calculate your probabilities first, then you can move for your expected frequencies. So before going to that you have to fix your null hypothesis, H0 the dice are fair, then H1 the dice are not fair, that is your alternative hypothesis. Again I can remind you, when you are going for any type of problem, be remind about your 5 different steps which you are following for any type of problem. The first thing you are going with your null hypothesis, second thing you are going with your alternative hypothesis, third you are going for fixing of level of significance and degrees of freedom, then in the fourth step you are going for calculation of test statistic, that is your chi-square, and finally you are concluding. These are the 5 default steps to be followed for any testing of hypothesis. It may be a chi-square, it may be a t-test, it may be a f-test. Please be reminded with that one. The level of significance alpha is 0.05, that is 5%, which is our third step. So initially first 2 steps are fixing your null hypothesis and alternative hypothesis. The third step is your alpha level of significance. With that you can also fix your degrees of freedom. Now we can see that the degrees of freedom will be n minus 1, that is 11 minus 1, which is nothing but 10, because you are starting the sum from 2 to 12. It means that totally 11 number of observations. So 11 minus 1, 10. So now we have been completed the 3 steps for the testing of hypothesis. So as you know that how the sum has been obtained, just have been given a clarity here. If you throw a pair of dice, you can get the outcomes as 1, 1, you have been having 1, 2 and so on 1, 3, 1, 6. Then 2, 1, 2, 2, similarly you can go up to 2, 6, similarly 6, 1 up to 6, 6, that is totally 36 number of combinations. So be clear about that here, you may be having a 36 number of combinations while rolling a pair of dice. If it is a single die, you will be going for 6, that is 1, 2, 3, 4, 5, 6, but here it is a pair of dice, hence you have to move for 36 number of combinations, that is as you see here 1, 1, 1, 2, like this you have to move for up to 6, 6. The sum of pair will be as like 2 will be the minimum sum, the maximum will be the 12. Now we can see the table here which represents about your sum, that is 2 to 12 here. Then you can go for observed frequencies. Yeah, here you can see sum is your starting from minimum sum 2, 3, 4 and so on up to 12. Now this is your observed frequency which we obtained from our given problem 8, 24, all these things. Now you have to calculate the probabilities. So as I already mentioned that totally you are having 36 combinations which is your sample space as per the probability. Then among that, to getting the sum, how many number of favorable cases are there? You can think now, to get the sum you have only one combination, that 1, 1, 1 plus 1 equal to 2. This is the only one combination where you can obtain to get the sum. So hence I am fix my probability as number of favorable cases by total number of sample space, that is automatically it will be 1 by 36. Now coming to here, you can see the sum 3. What are all the possibilities to get the sum 3? If you have been rolled the 2 dice, it may be a combination of 1, 2 or it may be a combination of 2, 1. You can see that 1, 2 means the first die is facing with 1, the second die is facing with 2. Whereas here the first die is facing with 2, the second die is facing with 1. So you have two different possibilities to get your sum 3. Hence the probability is 2 by 36. Similarly, for 4 you can think that there is 3 combinations. You can go with simple mathematics that what are all the additional possibilities for 4 with respect to 1 to 6. You can go with 1 plus 3, that is 1, 3 or 3, 1, 3 plus 1 or 2, 2, 2 plus 2. Those are all the 3 combinations you can work out to get your probability. In the similar fashion you can work out. Default you can identify here, it will be an increasing fashion, 1 by 36, 2 by 36, 3 by 36, 4, 5, 6. Whereas you can understand that for 7, to get a sum 7 you are having 6 combinations. It means that you can go with, just you can think about the combinations with each number. With you can go with then with 1. 1 means 1, 6, that is 1 plus 6 equal to 7. Similarly 2, 2, 4. Similarly you can go with 3, 3, 4. Similarly you can go for 4, 4, 3, 5, 5, 2, 6, 6, 1. You can see all the 6 combinations has been working. So 1 to 6 you can get your sum as 7. So totally the probability will be 6 by 36. Then again from 8 it will be slowly decreasing. At the end you can see that it will be 12. For 12 you are having one and only combination 6, 6 which is the maximum possibility you can obtain. So that it is 1 by 36. So up to the 7 you can get the probability as 6 by 36, later it slowly decreases 5, 4, 3, 2, 1, at the end you will be having 12. You can see over here 11, you can see 2 combinations, that is 5 plus 6, that is 5, 6 or 6, 5, 2 combinations. These are the probability cases you are obtaining here. Now as I mentioned that once you calculated your probability, automatically you can go for your expected frequency by multiplying the probability with respect to the total frequency. So here our total frequency is that you are conducting the experiment for 360 number of times. It means that the total frequency is 360. Then each and every probability has to be multiplied with 360. 1 by 36 into 360 means you can obtain as 10. Similarly 2 by 36 into 360 means it will be 20. Then 30, 40, it will be extended as like an increasing fashion. Up to 7 it will be 60, later it decreases again 50, 40, 30, 20, 10. These are all your expected frequency. Now you obtain your observed frequency and expected frequency both. Then the next automatic step will be your chi-square statistic. So here I have been given a clarity how you have been worked out just for your information here. E1, E2 and so on up to E11, how you are working here. Now you obtained your observed and expected frequency here. You can go for the calculation of chi-square test. So you know the formula that chi-square will be summation OI minus EI whole square by EI, that is 8 minus 10 whole square divided by EI. It means that divided by 10, where you can obtain your first chi-square value as 0.4. Similarly, you can go for 24 minus 20 whole square by 20, that is, it means you can get your value as 0.8. Similarly, if you run for all the calculation here, at the end you can go for 14 minus 10 whole square divided by 10, you can obtain the value as 1.6. Now, you got your chi-square value individually. As per the formula, it has to be totaled, that is the sum of all these values, that is 0.4 plus 0.8 plus 0.833, you have to add all these values and you can obtain your chi-square calculated value, that is the total will be 7.448, which is your chi-square calculated value. Then you have to compare your chi-square calculated value with your table value. I can show the formula here. This is your summation. If you are going for the summation irons from 1 to 10, it means that you have been adding all these values. This summation represents the meaning as like this is your default formula which you have been working for your chi-square. Now, chi-square critical value, that is n minus 1, 11 minus 1 will be equivalent to 10 and the value is 18.31. This is your table value. How can you obtain this table value? Yes, you can see the table. As I mentioned, this is your degrees of freedom and this is your percentages here. Now, we are moving for 10 degrees of freedom. For 5% level of significance, the value is 18.31, which is your chi-square table value. As I mentioned, earlier cases you have been working with the table sheets, you are moving with the fixed percentages, where if you move for the software oriented based, you can go with any type of percentages. Since your calculated chi-square value is less than your critical value, we will accepting our H naught. It means that you can conclude that the dice is fair. Dear students, we come to the end of part 2 of this lesson. In this part, we have been went with the calculation of goodness of fit for chi-square using probability distribution with a numerical illustration. I am confident that you understood the problem and the concepts which we covered in this part. We will continue in the next video. Thank you.